Assalamualaikum warahmatullahi wabarakatuh. My name is Fatimah Azizah Riyadi from the Bioprocess Engineering Program Study, Faculty of Engineering, Universitas Indonesia. Now I'll be talking about the biomass valorization and its potential to revolutionize sustainable resource utilization. So what is biomass valorization? So biomass is a diverse and renewable organic resource that includes plant materials, agricultural residues, and even the waste products. So valorization is the conversion of waste and this biomass to energy, fuels, and other useful materials with a particular focus on the environmental indicators and also sustainability goals. And therefore, the valorization of biomass means unlocking its hidden value, transforming it into valuable products, and reducing the environmental impacts. And the objectives of the valorization of biomass is also to optimize both cost and technical performance toward utilizing materials for multiple applications. So from the definition itself, why do you think that biomass valorization is important? So as a source of renewable energy, reutilization of biomass could reduce the dependency on fossil fuels and decrease greenhouse gas emissions. It can also provide an opportunity to manage organic waste effectively, reducing the burden on landfills and contributing to a more sustainable waste management system. Aside from that, when biomass is used for energy production, carbon dioxide released during the combustion or the burning process is offset by the carbon dioxide absorbed by the plants during their growth, making the net carbon emissions over the life cycle close to zero. And valorization of biomass can also promote the development of a bio-based economy, where biomass is used as a feedstock to produce chemicals, materials, and other value-added products, creating new economic opportunities and jobs. And it can also contribute to environmental sustainability by reducing the greenhouse gas emissions, improving the air and water quality, and also mitigating the climate change. So there are various types of biomass feedstocks that can be valorized, which comprise of first generation that is originated from the edible food source, such as the plants that are rich in sugars like the sugar cane, sweet sorghums, or plants that are rich in starches like corn, wheat, and barley, as well as plants that are rich in oils like olive, sunflower, and palm. However, as the first generation caused competition with the food supplies, there is also biomass from the second generation, which are mainly comprises of the non-food raw materials such as the non-edible oil-rich plants like the jatropha and also the lignocellulosic biomass, which is the most common one being used for valorization, which are mainly the waste of the residues from the agricultural and forests, such as the grasses, rice husk, palm oil, empty fruit punch, and a lot more. There is also the third generation of biomass feedstocks, which are mainly consist of the non-edible feedstocks that do not require agricultural lands for their cultivation, such as the aquatic biomass, like the algae and also the cyanobacteria, which are rich in lipids, proteins, and also lignocellulose. There are also recently the fourth generation of biomass resources that is developing, which comprises of the genetically modified organism, especially used to target the production of a certain chemical or products. And among these biomass resources, one of the most potential feedstocks for valorization is the lignocellulosic biomass, as it is abundantly available, does not interfere with food and feed supplies, and there are still a lot to be underutilized. Therefore, before we dive into how we can valorize the biomass, we first need to know the structure of the biomass that can make it capable to be converted into valuable products. So when we look closely to the structure of the biomass, it is actually a component of the plant cell walls, which are mainly composed of the cellulose, hemicellulose, and also lignin. Both the cellulose and hemicellulose are the chain of polysaccharides coming from the C6 and C5 sugar units, which can be depolymerized into smaller sugar units used as platform molecules, which can subsequently be converted into value-added products. Some of the most common products derived from these sugars are the bioethanol and biobutanol through various biological pathways and chemical processing. And aside from the cellulose and hemicellulose, the plant cellulose also contain lignin. Lignin is a highly insoluble macromolecule made up of aromatic polyphenolic monomer units joined by heterogeneous crosslinks. In fact, it is the most naturally produced aromatic feedstock on Earth. However, despite the high availability and low price of the lignocellulose, there is still strong resistance to its degradation due to the stable structure of the lignin, resulting to a substantial challenge in using the lignocellulosic biomass for certain application. So how can we convert these biomasses into products? Basically, there are three main conversion processes, which are the biochemical process, thermochemical process, and the physical process. Let's take a look at it one by one. So in the biochemical process, biological activators such as microorganisms can be a bacteria, fungi, yeast, or biocatalysts such as enzymes are used to degrade the biomass structure in the conversion process. So these process platforms are mostly focused on the preparation of high-value chemicals rather than the production of biofuels. There are two methods to transform the biomass using this method, which includes the fermentation of sugar source to produce biofuels like the bioethanol and the biobutanol, and there is also anaerobic digestion in which it is used to generate biogas, mostly the production of methane and carbon dioxide. The second conversion process is the thermochemical process, in which heat energy is used to resolve the bond of the organic matters through devolatilized, depolymerized, and oxidized activities, which can subsequently transform into solid fuel like the biochar, or synthesis gas, or known as syngas, and also production of bio oil in the form of liquid. The other conversion process is the physical process, and in this process, mechanical force is used to convert the lignocellulosic biomass into solid fuel, such as the pellets, biocoke, and also briquette through the densification process. On another physical process using extraction can also be used to produce bio-oils. Normally, a pretreatment process is needed to make the material handling become easier. In conclusion, biomass valorization is a pathway towards a more sustainable and efficient future, enabling us to fully unlock the potential of biomass resources. This approach helps to mitigate the environmental impact and create a circular economy that benefits the societies, the economy, and also the planets. So thank you very much for your attention. I'll see you in the next video.